distance formula from, or vice versa, is the Pythagorean theorem. Do you remember ever hearing about the Pythagorean theorem in the past? It's a really crazy word. You may have used it before. More than likely, you should have used it in algebra class, but it just depends on how far your teacher got. Okay. The Pythagorean theorem is for right triangles, and we are going to use it over and over and over again in this class. So make sure you get it down as we go through it. It only works for right triangles, so it only works for triangles that have a right angle. Now, in right triangles, we have three sides. The longest side, the one across from the right angle, is always called the hypotenuse. Okay? The other two sides, the ones that are touching that right angle, are called legs. Okay? So you have two legs and you have a hypotenuse. When we do the Pythagorean theorem, the legs are our A and our B. The hypotenuse is always the C. It's always the part over here by itself in the formula. The formula says that A squared plus B squared equals C squared. So if we take the length of this leg and square it, add it to the length of this leg squared, it will be equal to the length of the hypotenuse squared. That's the basics of the Pythagorean theorem. But we're going to try it out here with our example right down here. It said Maisie has a rectangular yard. What is the distance from one corner across the yard diagonally to the other? Okay, so we want the distance here, starting here, going diagonally across to the other side. Okay. Notice what shape we end up with. If we just look at the two measurements we have, the 5 yards, the 8 yards, and then the line that we're trying to find, what shape are we working with there? We're working with a right triangle. That's exactly right. So we can use the Pythagorean theorem. So remember, in the Pythagorean theorem, the side across from the right angle is always our hypotenuse. So this right here is our hypotenuse. That's our C. The other two sides are our legs. This would be A, this is B, and this side is C. So we go ahead and set up the equation. The equation said, in a right triangle, A squared plus B squared equals C squared. Okay? Put in our A and our B. So the legs of our triangle were 8 and 5. We don't know the hypotenuse. That's what we're trying to find. That's our diagonal distance across Maisie's yard. Okay? And then we just go one step at a time to solve this. So the first thing we're going to do is square 8 and square 5. What do we get when we square 8 and square 5 individually? Close. Make sure you're taking them times themselves and not times 2. That's a common thing that happens. So remember, 8 squared means 8 times 8, or 64. And 5 squared means 5 times 5, or 25. Oh, that's okay. I'm glad you did that. You were doing that so that everyone watching the recording would know not to, because that happens all the time in geometry. People forget that. Okay, now we add those together. So 64 plus 25 gives us 89. Very good. And we're still trying to solve this for C. The problem is that C is squared. How do you get rid of a squared? When we want to get rid of addition, we subtract. And when we want to get rid of multiplication, we divide. What do? What's the opposite of squaring something? Anybody? Any ideas? The opposite of squaring is the square root, and that's how this is related to the distance formula. Because when you're trying to find c, you're basically doing the square root of a squared plus b squared. Okay, so that's how the two are related. The distance, c, from one point to another is the two lengths squared, and then the square root of that. So to get rid of a squared, you take the square root of both sides. That cancels the squared so that I just have c. And then on this side, all I have to do is do the square root of 89. And we do get 9.4. Yes. So that is how the distance formula and the Pythagorean theorem are related. It's like we're trying to find the distance between 2 points. Okay, and we would find the distance on the x. This would be x minus x here. This would be our y distance, our up and down distance. This would be y minus y squared. Okay, so that's how the two are kind of related. Actually, they're really related. We used one to get the other formula. Okay, let's try this one. All right, this is an example. It's a story problem, which we love. It says, Red Square in Moscow, Russia separates the Kremlin from the official residence of the President of Russia. Okay, so it's just kind of an open courtyard. It says, Red Square is 330 meters long and 70 meters wide. So I'm going to label this. Does that look good so far? So we have this open courtyard in the middle of all these government buildings, and it's 70 meters wide and 330 meters long. Find the distance to the nearest meter from one corner of the complex to the opposite corner. So we want to go from one corner to the opposite corner. We want that distance. What are we going to use in order to find out how far that is? Okay, so one thing we might take a look at is what shape did we end up with? What shape did we end up with when we take into account the length and the width and then the distance across the courtyard? What kind of a shape do we have? We have a right triangle, and anytime you have a right triangle, what can you use to find one of the missing sides? If you have two of the sides, we have something we can use to find that third missing side. What can we use? It's hard to spell, but again, it's called the Pythagorean theorem, yes. And it's just a squared plus b squared equals c squared. Okay, so again, a and b are your legs, and c is that hypotenuse. It's important to keep those in order. Let's put our numbers in. So one of our legs was 70, the other was 330, and we don't know what our hypotenuse is, so I'm just going to call that c. First step is to square the 70 and the 330. So what is 70 squared? And remember, it's 70 times 70. Yes, go ahead. Go ahead and give your answer. If you've got the full answer, and we'll just check it as we go. That's good. Good, Nicole. Yep, that would be, I'll take this little pointer thing away. That would be 4,900, and then square 330. Well, that's a big number. It's just 108,900. Okay, we're going to add those together. We get 113,800 so far. What is our last step going to be? We still are not done because our C has a squared on it. We got to get the squared off to get our C. So what's the last thing we're going to do here to finish this problem? Yeah, so we're almost there, but we need C all by itself. And remember, to get rid of a square, we do the square root. So that then we just have a C and take the square root of the other side also. Okay, so now what is our answer going to be? It said to find the distance, yes, to the nearest meter. So you do get 337.3, but we want to round it off to the nearest meter. So the diagonal distance across red square is 337 meters. Very good. Okay. And one thing you might look at is when you came up with 113,800,